Hello and welcome to Forbest Academy, and welcome back to our AMC 1012 breakdown videos for the 2021 paper. We're going to be looking at some past paper questions, breaking them down and looking at the concepts involved. And starting off this week of AMC 12 questions, we are looking at this question here. The closed curve in the figure is made up of 9 congruent circular arcs, each of length 2 pi over 3. Where each of the centers of the corresponding circles is among the vertices of a regular hexagon of side 2. What is the area enclosed by the curve? Now, if we look at our diagram here, we can see that hexagon very clearly. And we can see that the way that splits our arcs, that each of these arcs has got a radius of 1. Because if our hexagon has a side of 2, then clearly our arcs must each have a radius of 1. Now, looking at these arcs, it looks like each one is 1/3 of our entire circumference, but we should check that. If we have a radius of 1, the entire circumference would be pi times 2 times the radius. So we've got 2 times pi to give me an entire circumference of 2 pi. So therefore, 1/3 of this would be 2 pi over 3. So this arc is exactly 1/3 of a circle. So if we want to work out the area enclosed by this curve, the way we're going to break that down is into 2 sections. Firstly, we're going to look at the area enclosed by our curve outside of the hexagon. And then we will look at the area enclosed by the curve inside of the hexagon. So starting off, we have 2/3 of a circle here. The radius is 1. So 1 squared multiplied by pi would give me the entire circle as having an area of pi. So 2/3 of the circle would be 2 pi over 3. We have 3 of these. So that gives our total area outside of our circle, outside of our hexagon rather, as 2 pi. Now inside a hexagon, we can see that things are slightly more complicated, but the way we could work this out is by working our entire hexagon area and subtracting our 3 sections here. So to do that, though, we need to work out the area of our hexagon. Now, we should remember from previous lessons that hexagon can be divided up into 6 equilateral triangles. Now, to work out the area of that equilateral triangle, we need to work out its height. Now, we should know by now that with an equilateral triangle, if we want to work out the altitude of our equilateral triangle, then it will always be equal to √3 multiplied by half of the base. So for instance, if we had a base of x, the altitude of this would be x times √3 over 2. In this instance, our base of each of these equilateral triangles is 2. So therefore, our altitude will be 2 times √3 divided by 2, which is going to give me an altitude of just √3. So therefore, the area of each of these triangles will be √3 multiplied by 2 divided by 2, which will just be √3. So the total area of our hexagon is going to be 6 of these triangles, so 6 lots of √3. Now we look at our sections of underneath our arcs inside our hexagon. We have 3 sections here. Each one is 1/3 of a full circle. We said the area of 1 full circle was pi. So therefore, each of these is going to be pi over 3. We have 3 of them. So therefore, the total area is going to be pi. So if we want to work out this interior area enclosed by our curve, it's going to be the total area of our hexagon, 6 √3, subtract pi. And if I add these two terms together, our area outside of our hexagon plus our area inside a hexagon, 2 pi minus pi is going to be pi plus 6√3, which is our answer E. So key facts from this question is remembering that hexagon can be split up into 6 equilateral triangles. Remembering how to work out the altitude of an equilateral triangle. If you are struggling to remember that one, then one of the ways we can do this is by quickly using a little bit of Pythagoras. The most simple example of that is to think of a situation like this. Square root of 2 minus 1 gives me 3, square root of 3. Thanks very much for watching this video. If you enjoyed it, please like and subscribe, and stay tuned for the rest of the week where we will be broadcasting more past paper questions broken down for you. Thanks for watching, and I look forward to seeing you again tomorrow.